Let us now apply these concepts of equations into motion analysis. And motion analysis requires one to understand the concept of speed, distance, and time. Speed is a variable, is indicated with the variable v. Distance is indicated with a variable s, and time with a variable lowercase t. The relationship between these three parameters is as follows. The velocity, or the speed, is the change or the distance traveled divided by the time required to travel that distance. So if one knows the distance traveled and the time required to travel that distance, it could find out the speed by which the motion took place. If one knows the distance traveled and the speed by which the distance got traveled, one could solve for the time required for the motion. And if one knows the speed and the time, then one could find out the distance traveled. So these three equations are as follows. V is S over T, T is S over V, and S is V times T. So in these equations, we can recognize dependent and independent parameters, and we can recognize the concept of a slope and the concept of the constant. In these cases, the constant is zero, which means that when when the independent parameter is zero, the dependent parameter is zero as well. So in the first equation, if the distance traveled is the independent parameter and the speed is the dependent parameter, then the slope is 1 over t. The second equation, the slope is 1 over v. And in the third equation, the slope could be the time, or it could be the velocity. And the reason we put these slopes is to keep the equations in the linear form. The slopes will be constant. Let us now see an example. Let us assume that we have somebody who is driving a vehicle with 10 miles an hour. And this person is driving the vehicle for 5 minutes. We would like to find out how much distance this person traveled. The equation that we will use will be the third equation. The distance traveled is equal to the speed times the time. So here we find, if we substitute the values, 10 miles per hour times 5 minutes. We know that the distance traveled will be units of length, which are, in this case, miles. So if we look at the units, we need to convert even the hour into minutes or the minutes into hour. In engineering, many engineers and even federal agencies get into big trouble by mixing units. So do not ever drop units from your equations. Always keep the units in order to facilitate and solve for the correct quantity. So here, what we will do, we are going to substitute hour with 60 minutes. And of course, after we perform the substitution, we can cancel out the minutes from this equation. And we observe that there is a further simplification. 10 with 60, 10 divided by 60 gives us 1/6. And the answer to our problem is 5/6 of a mile. And of course, one could now find out the corresponding distance in kilometers or meters by performing the proper conversion from miles to those appropriate units of interest. Let us now assume that we have the same person driving this vehicle, but the velocity, the speed with which you are driving remains the same, 10 miles per hour, and the distance traveled is, say, 5 miles. We are interested to find out how much time does it take to cover these 5 miles. So the time required can be found by using one of the earlier equations, which gives us the time as the distance traveled divided by the speed. So if we substitute in here the values, we have for the distance traveled 5 miles, and for the speed we have 10 miles per hour. Well, here is straightforward to say that this is going to be 1/2, but then in what units? We have to be careful with the units. What do we observe? We observe that the units are a nested fraction. So let us write this out. This is going to be 1/2. So if we revisit our nested fraction idea or analysis, the units could be written as miles times hours over miles. We take the denominator of the nested fraction and invert it, and then multiply it with the numerator of the nested fraction. And in this case, the nested fraction is just the units. When we perform this nested fraction analysis, we find out that the units of distance cancel out, and our final result is 1/2 hour. And of course here, we can take an extra step and say 1/2 hour, 1 hour is 60 minutes, and then we can find the time if we would like in minutes, which is 30 minutes. Always use your units. Never try to avoid carrying your units across and using them in finding your results. Here, if I had given you the answer as t equals 1/2, you would tell me what time of units. Minutes, seconds, hours, centuries, years. So it's important to keep track of our units.